So let me tell you today more about how robots can completely transform our data collection operations at sea, how they can make these operations a lot safer, efficient, and a lot more sustainable. What you see here is a multi-beam echo sound. These are two different types of multi-beam echo sounders that are very commonly used in the market. Those are very compact sensors. They typically weigh no more than 15 kilograms and are less than 30 centimeters in their longest dimension. These acoustic sensors transmit acoustic signals towards the seafloor, measure the time it takes for an echo to come back, and based on an estimate of the sound velocity, they calculate the depth of the seafloor at different points. Traditionally, these sensors allow us to create a 3D model of the seabed. So when we take those depth estimates and combine them with our knowledge of the position of these sensors, we're able to create these nice 3D models of the seabed. These models are very important for those who want to navigate the seas and for those who want to carry out nearshore and offshore construction projects. Additionally, when these sensors are deployed, we need both a crew and a vessel. The crew typically consists of a surveyor, someone that can configure the sensor, adjust the gains, make sure he gets the right data, and the captain that can drive that vessel. The vessel needs to be big enough to accommodate the crew and all the amenities, like whatever they need, the toilet, a tank of fresh water, and a climate-controlled cabin. As you can see, this is a very labor-intensive, very energy-consuming process. We have to move the entire crew, all of these amenities, just to get this sensor moving around a specific area in the sea. This is where USVs, or Unmanned Surface Vehicles, come in. They allow us to take both the captain and the surveyor out of the vessel, put them in the comfort of the ground control station. We don't only give them comfort, but we can also perform the same operation a lot more accurately, since these robots are much better at driving in straight lines than the captain typically is. Taking the human element out of these vehicles also allows us to shrink down the size of these vessels significantly, like this two-man deployable USV that you see here. Freeing up space also allows us to give room to very much needed energy storage mediums, such as batteries and fuel tanks, so that we can operate for much longer times at sea. Here you can see similar multi-beam echo sounder on all the USVs that we've worked on. Taking the human element out of the vessel, out of the boat, also allows us to optimize its design for other parameters. We can optimize these vessels for stability and for its hydrodynamic geometry. Like this vessel you see over here, there is absolutely no room for a cabin or a toilet, but it's a lot more hydrodynamic and a lot more stable, allowing us to collect data in rougher sea conditions. What we see in the slide is the UAE's beautiful coastline. While this is a great blessing, it also presents a challenge to law enforcement agencies. In maritime security, there's another opportunity for using USVs. Traditionally, coast guards deploy fleets of patrolling vessels and a network of surveillance sensors like these coastal radars and some long-range daylight cameras and different types of infrared cameras. Let me show you a bit what these sensors can do. So on the top left corner here, you can see the image from a daylight camera. This is of a boat that is at least 15 kilometers from shore. And this is from a state-of-the-art system, one of the best systems available in the market. As you can see from the daylight camera, the fog completely obscures the details on that vessel. We can't really tell what kind of activities are going on, we can't really tell the type of the vessel that we're looking at. In the bottom left, we see another image of a similar boat at a very similar distance, this time from a SWIR sensor or a shortwave infrared camera. This sensor does a much better job cutting through the fog, so we can see the vehicle, but we still cannot tell any details about what sort of activity is going on that vehicle. On the right over here, we can see a radar video overlaid on the map. While the radar does a really good job covering a big geographical area, it tells us little to no detail about the different types of vehicles or vessels that are in our local waters. So from these examples, what I wanted to show you is that these sensors give us a very good idea of what's going on in our local waters, but they still don't eliminate the need to sometimes send out a patrolling vessel to go and get a closer look on what's going on. Now, this is not only completely inefficient and takes a lot of the time of these law enforcement personnel, but it's also risky, especially when the sea conditions are rough. Here, USVs can also be a complete game changer in this area. The USVs can carry similar sensor suite, again, electro-optical cameras, infrared cameras, and radars as well. These allow us to go get a closer look of what's going on in our local waters without putting the lives of law enforcement personnel at risk. So it virtually creates an additional layer of surveillance. And what's nice about that layer is that it's mobile. We can very efficiently reposition these sensors along our coasts. Taking the human out of these vehicles also allows us to design new types of vessels, like this sailing USV. This sailing USV also carries a radar and electro-optic sensor, infrared cameras. It harnesses wind energy to propel itself and uses solar panels to power its electronics. So it can virtually patrol an area for an unlimited period of time without the need for it to come back and refuel. The applications of USVs and the potential of using this technology is not limited only to seafloor mapping or maritime security, but it also extends to other very dirty and dull applications like pipeline inspection and environmental monitoring. And it can also address a lot of the challenges that we face at some dangerous operations at sea, like minesweeping and firefighting. I hope that this talk inspires some engineers to join this field and maybe help us crack some more of these puzzles that we face daily in developing the technology behind these USVs.